Type B. Uh, type ID. Type type one. Type one A supernova caused when a massive star loses mass from his companion star. And other one is type 1b supernova is a supernova without is is a type 2 supernova but without its atmosphere. Thank you. Done.
Tell me
So
something about.
Aryan,
Hmm.
yes, definitely.
This
Yeah, Aryan, tell me something about the ISRO.
Yes, and right now Chandrayaan is
about
where he is right now.
And what is this Chandrayaan 3?
the Indian Space Research Organization, commonly referred as ISRO, is the National Space Agency of India. It operates under the Department of Space and it was created on 15th August 1965. Um, ISRO has launched many missions like Mangalyaan and Chandrayaan. Chandrayaan 3 was launched on 14th July in Andhra Pradesh, and it successfully got launched. Um, and its headquarters are situated in districts of Karnataka and Bengaluru. Yes, them.
So,
So
tell me something about our Indian scientist. Do you know what is the name and he's from belongs to and what is the specializations?
What?
Our Indian scientist. Do you know what is the name?
Um, doc- Dr. Kalam, who was born in 1931 and died in 2015. He he was he launched the SLV rocket, and and one of the and he launched many rockets and some of them failed too. And he was born in October 15, 1931 and in Rameshwar. Dr. Abdul Kalam. Hello, can you hear me?
yes, you are audible, Aryan.
I think I should repeat again.
Yes,
APJ Abdul Kalam, one of the most Indian famous scientists, and he was born on October 15, 1931 in Rameshwar, Tamil Nadu. He presided over India from 2002 to 2007 for Silicon. He began his career by developing helicopters for the Indian Army as a aeronautical engineer for the Defense Research and Development Organization. In 1969, he was moved to India Space Research Organization (ISRO), where he served as projects director on SLV-3, the nation's first launch vehicle, which was successful in putting the satellite Rohini into a near-Earth orbit in 1980. He was also known as Indian Nuclear and Missile Products Advanced Quickly. The Missile Man of India, APJ Abdul Kalam, passed away on 2015. Subramanya Chandrasekhar, astrophysicist and Indian scientist. Subramanya Chandrasekhar won the Nobel Prize in Physics in the year 1982. He won the Nobel Prize for his work examining the physical mechanics involved in the formation and evolution of stars. His most well known discovery was the possibility of a big star collapsing due to gravity to achieve infinite densities. And he is also known for his Subramanya Chandrasekhar limit, a limit for white dwarfs. Thank you. Done.
Okay. So, good evening, Prem, Brenda.
Good
Today is your
evening.
Science Day.
Good evening, all of you.
So, you want to say something regarding science, Prem? You know, your background is also commerce, banking sector, but
Right,
sir
right.
always told us
No,
it's
science is totally new for me.
common for
I'm also curious to know various things happening around me in a space, around world. So, science is not, limit. Maybe medical science, maybe, different kind of science is there. Human science, even though spatial science. I also I also have to learn various things from Aryan also. Astrophysics, right? Various things.
Yes, sir.
So, Aryan, do you know Elon Musk? He's also planning for the Mars. Do you know?
Yes.
Okay, tell me something. You have only two scientists mentioned. So you can also do you know about the
I
Rakesh
also know about Ramanujan.
Ramanuja? Acha. Okay. So tell me something about the Elon Musk. He is also planning for a space. He is much interested about the space also.
Um,
You can
about
also yeah, you can also on your video when you have speak.
uh, Elon Musk. Uh, Elon's Musk SpaceX company. Elon Musk is a business and investor. He is the founder, chairman, CEO, and chief technology officer of SpaceX. And he and he and he was born. I think he was born in 1971. Elon Musk is the CEO of SpaceX. Elon Musk is the Elon Musk is also the chief designer. He develops of rockets and spacecraft for mission to Earth orbit and ultimately to other planets. This company, SpaceX, is also known for its innovative technologies, successful landings, and reusable fuels, reusable rockets, and it is planning to colonize Mars.
So Brenda, you want to say something or you have any question regarding Aryan?
Yes. When I was a kid, a child, I see in TV about the rain of stars.
What?
Rain of stars.
Brain of stars?
Rain.
Rain of stars.
Yes.
Oh,
I don't know if you know about that or you can explain
mm,
what happened with the stars.
mm.
Every planet has a different rain, na? Aryan, you can speak about them, na?
Brain of
Rain, not brain, betu. Rain.
Yes, rain.
I didn't understand.
So
Brain
Brenda,
of
can you explain
stars.
first? Rain, baris, baris.
Rain
Rain
of rain of
Yeah,
stars.
stars.
rain
It's like a rain of water, but in this case, it's rain of stars.
stars. Oh, I'm thinking right now.
Okay.
So Brenda, can you explain? Then after I think I will.
Are you talking about meteor shower?
Yes, but in this case, I don't know if the star is a meteor, but yes, it's a similar
Yes.
meteor shower.
Meteor
Yes.
showers occurs annually or at regular intervals, and they could left some debris by a comet. Meteor showers are usually named after a star or constellation. Mm, yes. Meteor shower occur annually. Um, Meteors can appear anywhere in the sky, and the more sky you see, the better your chances to spot one. And there are many meteor showers, but I don't know their names. They are also called shooting stars, and they are common. Shooting stars are common.
And
They and I also have seen one.
and it's possible touch the stars.
What?
It's possible touch the stars.
Mm, I didn't understand.
Touch, touch to a
Touch
star.
the touch the star. Oh. Um, if you touch a star, you'll be instantly vaporized. Not instantly, you will, but there was a probe that touched the star. Um, it was launched on, I guess, 2023, 14th December.
In December, it's most possible that shooting stars.
NASA's, yes, yes. NASA's Parker Solar Probe is the first ever mission to touch the star, sun. Sorry. The spacecraft, about the size of a small car, travels directly through the sun's atmosphere, ultimately to a distance of about 4 million miles from the surface.
Okay, and what happened in this mission? The mission of Touch the Stars. What happened in this mission?
And okay, we can't touch this star, because it is made up of gas. You can only touch the gas.
The composition of the star is a gas.
Yes, it is made up of hydrogen, or it is made up of plasma. It is made of plasma.
Okay, thank you for explaining. And what is the status now about the mission for Chattarian? I don't remember well the name, but this is the mission of three
Chandrayaan 3.
launches.
Yeah,
Ah,
Chandrayaan.
okay.
About
Chandra 3.
Chandrayaan 3.
your Hindi is too much. Matlab, funny.
Okay,
Sorry.
Chandrayaan 3.
Yeah. You can
Yes.
talk.
Chandrayaan 3
Yes. What is
is
the
a
status now?
third and most recent lunar Indian space research exploration mission under Chandrayaan program. It consisted of a lander named Vikram and a rover named Pragyan, but does not have an orbiter like Chandrayaan. It was launched in Andhra Pradesh. It started at 14th July 2023. It is almost 3.9 tons heavy, and it has a budget of 615 crore. Yes, and is
And Aryan,
yeah,
as per last session by Amarnath sir told us, our mission is not only touch to Chandrayaan. Yes, our mission is something as like calculation, something what is.
yes,
So can you explain something? What the purpose? Chandrayaan 3.
yes, okay.
Chandrayaan 3 is not
Okay.
only visit to Chandrayaan. Yes, visit to moon. So something
Are you
purpose.
asking the purpose of
Yes,
Chandrayaan?
yes.
Okay. Chandrayaan 3 mission has three major objectives: demonstrate safe and soft landing on the moon surface, conduct rover operations on it, and conduct on-site experiment on the lunar surface.
Namaste, sir.
Hello, namaste everybody. How are you all?
Fine, sir.
Fine, sir. Actually, just received a message from Chaturanga Malik, sir. He's not well, so they told me I will join from next week. So
Yeah, I
today
think
I will not join.
he had gone through the dental surgery, not dental, I think eye surgery for cataract. So that's why probably he's resting today. Yeah, I also got a text message from him.
Yes.
So how is everybody doing? So what is the topic of today?
Yes, Saturday night is only for science.
Yeah, I see that there was a big meeting in India for the semiconductor industry. Did you guys hear about that? Modi ji had a big meeting.
Delhi, Delhi, G20 some G20.
No, 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 no. Or for the semiconductor industry, there was something I saw in the news a couple of days back.
Yes, yes. Maybe in Gujarat, planning for manufacturing units start for semiconductor.
Yeah, yeah, that's what I'm talking about. There was so yeah. So basically, they want to start the semiconductor fabrication right now. Basically, what is happening is that we are buying semiconductor chips from everybody else. And as you know, now there is not a single type of machine which you can make without computer chips. There are different types of chips, computer chips, which are used in machine. Some is used for like a brain. Brain is doing thinking. Similarly, that type of chip is called CPU. So that is one type of chip. Then there is another type of chip called memory chips, which is like, remember everything, just like our mind. We remember, we store information. So there are chips who are for the storing the information. Then there are chips for functioning like hand job, driving. You call it controllers. So there are controller chips. That's another type of chips. And like that, there are so many. Basically, in these three varieties I gave you, there can be from three to different 300 different types, specialization in everything. But basically, you need chips to make modern machines. Any machine you can think of. There is not a single industry which is not impacted by computer chip. Medical industry, aerospace, rocketries, car, all the equipment which you use in the hospitals. So nowadays it is just like you can call it just like, we cannot live without oxygen. Same way, the modern manufacturing you cannot imagine without computer chips. And India missed it both in 80s when everybody was Congress government big failure. We could have started these things in 80s, but we missed it. Other countries, small countries like Singapore or say Taiwan or Korea and Japan, they jumped on it as soon as semiconductor was developed in the late 60s and 70s, and then they started utilizing it. And they leaped forward. They become rich. All these countries have become rich. One of the main reason is that they made tons of money by selling computer chips. Singapore, Taiwan, Korea, like you all know that uh, one of the major applications of chips has been in the telephone. And telephone boom happened only after the computer chips was developed. And we were sleeping. But now we are trying to wake up, so which is still not late, because someday you have to wake up. There is no choice. You cannot depend, otherwise you'll go bankrupt. Imagine if everything you are going to make, you have to give a big cut for everything, for the most expensive part to other countries. So basically, um, your your what you call your engineering contribution is not going to be big, because other machines, anybody else can. It is like the frame, making frame. If you are making simply the frame of a car and you don't make the engine, you don't make a lot of money. It is the engine and controllers where the money is, which is driven by computer chips. So anybody can make the steel plate or whatever it is, or the glass windows, right? So uh, yeah, if we have to pay the royalty to all these foreign companies, we will go bankrupt. We cannot do it. So it's good that its country is waking up. And I would like you guys to ask me, since that is my field of work. I can answer questions if anybody has any question on semiconductor. Since Malik is not here, so let's change the topic. I don't think I can do anything on the rocketry, which normally Aryan has questions. That's not my field. So Aryan, any question on semiconductor you have? No.
I think,
Okay.
sir,
Yes,
nowadays, a small to small, like a remote control of television to big, like aeroplane, semiconductor role is always present.
That's correct. So, a computer is a semiconductor is basically the most important part when we say is uh, the computer chip. What is computer chip? When we say it is, it is what you call is how to make the what you call transistor to work. I think I'm going to share something on my computer, since
Sure, sir.
that would be a better way. But you cannot record it, what I'm going to share, because that is a people are making that right now in the manufacturing, many companies. So make sure that starting this discussion. So let me just turn on the computer while I can still be on the phone, and see if I can pull up something I want to share with you guys. See if it's I can do it quickly.
Okay, sir.
Can you send me the link on the email, Pankaj?
Yes, sir.
Okay, just send me the link on the email so that I can use it on computer.
Which mail ID, sir?
Jhaamar31@gmail.com.
Okay, sir.
sir.
Yeah.
You can explain fear the semiconductors because I think it's a first question for me because semiconductor for me is like a silicon and germanium and both elements.
Yeah.
You can explain who
Okay. Yeah, that's what I'm
have.
going to. I wanted to bring this something which I can talk about. Semiconductor. Let's see, class 12.
Sir, I sent a mail.
Okay, you sent me. Okay.
Amar31 @gmail.com.
Okay. Transistor. Okay. All right. How it
Yes,
works.
just because the transistor is the component of transistor is a silicon and I think germanium.
Yeah.
So,
Okay.
sir, who is founder of semiconductor?
So this patent was done here in 1960s, and I don't remember who was the real um, transistor patent, but it was done in Bell Labs. Bell Labs was here in the New Jersey. It was established right here where I am in New Jersey area. So Bell Lab used to be the biggest scientific place in this area, and they developed this. All right, introduction to bipolar junction. Let me see. I'm trying to find a YouTube video which I can use. So basically, what it is, transistor is that. Let me first, while I give you the background. Basically, let's take a road. I'll do or a river. Everybody has visited a dam. Anybody has not seen a dam where the water is on one side and then there is a dam which has a sluice gate, and then like hydroelectricity is generated by using that water which is stored on one side, and there is sluice gate. If you have too much of water, like rainy time, then you can simply open the sluice gate and water will flow so that you will not have a flood or anything like that. Have you seen? Everybody has seen that one.
Yes,
I hope
yes,
so.
Yes.
Yes. Okay. So same concept. So what happens there? You let's call it that gate, water gate. So you have one side a water gate, and other side consider it a canal, a canal for the water. So suppose you have a stored water, and then the canal is there on the left hand side. You have a stored water, a dam, and then you are sitting on the dam sluice gate on the top of it, and then you have the key of that sluice gate, and the right hand side is a canal. Now you want to discharge the water into canal. So what do? You would open that sluice gate. As soon as you open that sluice gate, water slowly will start flowing through that sluice gate, and it will go to the canal. You have control of the sluice gate, right? If you open it more water will flow through the sluice gate and more water will go to canal. You can control it, right? If you want
yes,
your canal to be full, suppose it is a rice season or wheat season, you need a lot of water, then you will fill the canal to its full capacity. You open the sluice gate to full capacity, and then whatever canal has the carrying capacity, it will take all water, and then it will flow in the canal, and then all the fields connected to canal, you can start utilizing it, right? Wheat or crop or whatever you have, all the farmers can use it. Okay, so this concept is clear to everybody, right? So what happened now? You can you have two part. On the left you have a storage place, and on the other side you can call it a drain place, right? You are draining the water into the canal, and then you have a gate. All right, exactly, this is what was conceived by those people who initially started experimenting with the semiconductor. They said that they figured it out that electrons was not electron was known, like we have Bohr, we have Rutherford, all these people, they knew that electron has a lot of power in it, and they started thinking, how can we utilize more this electron as water particles, just like I gave you example into this canal source which is our lake, and then sluice gate, and then we have drain. uh, Same thing. They got the idea that how can we do the same thing, and they eventually they were able to figure it out. They were trying to see how can I flow electron from one side to another side, And when electron flows one side to another side, then we can think of, once we learn that one, then we can think of application. Just like, when you can throw the water from the source lake to the drain on the canal, now this water you have in control, you can use it for different application. You can use it for farming, you can use it for industry, you can use for many other things, or for drinking. It is up to you where to utilize it. So, but the key
As per
part,
requirement.
as a requirement, the key part is now you know how to control the water, right? Similarly, they wanted to master the art, how can we control the flow of electron. Okay, so that is how the electronics first patent came into picture. So basically what you have in the in this one is, you can call it a source and a drain. I was trying to see if I can draw a picture here on the computer, or maybe I find a transistor picture that will be easy to.
Aryan, you raised hand, so you have any question?
Yeah, go ahead, Aryan, if you have any
Yes,
question.
sir. Yes, sir.
Yes, please, please.
Sir, where is the biggest telescope located?
That question, I think, is this the Hubble telescope that I think is the biggest yet, but it is
Okay.
in the space already, Hubble telescope. If you are talking about a telescope which is somewhere on the ground, there are many telescopes in this country, and I think United States has several. I was already talking about the Arizona one, but I don't know which one is the biggest. So I don't have that good answer for where the where that is. Um, okay, any other question, Aryan? Let's see if you have any question about transistor.
Sir, how do AI work?
Okay, so basically, artificial intelligence is um, okay. So that is what we are talking about. Artificial intelligence is nothing but use of the uh, computer chips. So basically, what is art? There is AI, means artificial intelligence. First, you have to understand what is intelligence. What is intelligence? Intelligence is nothing but our brain has God gifted, you can call it, or nature gifted capability to compute. Our brain is over the billions or millions of years, and I'm not a biologist, just maybe somebody else can explain, but basically, our brain has developed, and now our brain can think and it can compute. It can do a lot of things. So computing is
The
nothing but a
ability to survive.
huh?
The ability to the
Yeah,
ability to survive.
ability to think and ability to make decision. That is the better way to call it, since we are making it application. So you make decisions, right? You, like, for example, your brain, when you are walking anywhere from your apartment to, let's say, you go to school, you don't know, but do you know that your brain is making how many decisions? Every step you take to go to your school, your brain is making decision, and it's giving its signal to your leg that direction of the school is in this way, so you need to move into this direction. If you start going in the opposite direction, the brain sends another signal. Oops, you are going in the wrong direction. You cannot do that one. Okay. So apparently, you and I, when every day our brain is making every second thousands of decisions, like right now, your brain is listening, it is making decisions. What it is doing, it is whatever word speech I am making here, it is communication is happening, it is going to your brain. Your brain has different collectors of signals, by I don't know what they call it in the scientific term, neuron or whatever it is. and those signals are again converted by different energy, electrical or whatever it is forms, and then those signals are in such a way presented to your brain that it can make sense out of it. And then you say that, oh, our uncle is talking right now about semiconductor, how it works. Okay, so so your brain makes a sense out of it, but ultimately what is happening? Your brain is computing, it's making tons of decisions. It's never until we are awake. When we are awake, we are making thousands of decisions. And even if when our brain is not even it idle, it doesn't stop, it keeps irrationally thinking. And that's why you are kind of daydreaming, or you're, even if when you are walking, your brain is suddenly thinking about some past event. So it's engaging, it's pulling the memory from your things in the past, and then it appears as a dream or even as a daydream. You are walking, and but you are thinking about a class, something happened like 2 days back, and you have a test. So you're memorizing about that thing because you have to give a test right now in the school. So you are pulling that information from your brain. So all this is nothing but the computation. Okay. So this is decision making. So that is what is intelligence. Now, artificial word, it tells it itself that now that intelligence which is God gifted to you or nature gifted to you, now you are snatching that information from God or nature and trying to bring it to your fingertips by human, it is going to be available to us. And that is the reason we call it artificial. It's not natural. So it is the decision making capabilities of our brain is now converted into your artificial function, where just like your brain is doing, you can do it. So in the scientific term, brain is doing three things all the time, either doing yes, or it's saying no, or it is just what you call stray. It doesn't do anything. There are three things happening. Anytime you make a decision, there are three choices. Either you want to do it, or you don't want to do it, or you want to be on the sideline. You don't want to make decision now. Okay, you defer that decision for future, right? So, so and uh, so like all these, so basically it has been uh, by artificial intelligence, we have created intelligence now. As you know, in the computer is nothing but intelligence. Have you played a chess? Now you can play a chess with your computer. If you have at home, you can try it. So now what you do when you play, two person are playing chess, each person is using their brain. But now on the other player, if it is computer, now computer is doing thinking. And then now I mean, in most of the 99% of time, you lose when you play with computer. Because what happens that computer has been given all the possible answers artificially, it remembers, and it has a decision making process where out of all the different choices, whatever is the best choice, that is what is going to pick when it makes next move, when you play chess with the computer. On the other hand, we have all the choices, but it is very hard for us to remember all the choices. So we pull maybe the top five choices. Instead of, suppose there are 100 choices, we pull the five top choices which we have used more frequently in the past, and then our brain tried to pick the best out of the five. So what happened? Our Since we are trying to utilize our own memory, we could only come up with the five choices. But computer, which is artificial intelligence, has its disposal 100 choices. So it is making the best choice out of 100, and we are making the best choice out of five. And so we always lose to computer. We never win the chess. That's why we always fail. Okay. So it tells you that how powerful the intelligence of the computer is. Now, exactly the same power, we want it to harness it at everyday life. And that is what is happening. This Now, to do that, like a computer chess example I gave you, it is still in the computer, it's very limited. Action, I gave you example of a computer chip. But think if I expand that, playing like a chess, all the activities which we do in our daily life, like when I go to the office, what I do in the office, there are a bunch of decisions I have to make. I have to look at the data, and the data based decision I make. You go to the class, you have to solve some problems. Pankaj goes to his office, he has to do his operations. Uh, Brenda goes to her office, her electronics, she has to do some software things. So all the activities which we are doing it, we are making this intelligence calculated based on our training. We are making decisions. We are uh, we are converting one input into a output which is a better output, which has more value in it. Okay, so input is less valuable than the output, right? At the end of the day, if you ask me what I did in the office, I did something, right? Your parents, your father, they did something. But what he did, he converted the lower value thing to a higher value thing at the end of the day. That's what we do for all everybody, all the humanity, right? So it is being done by you and me, your parents, right now. Now think about it. Just like you gave the chess game to the computer, if you give this whole activities which we all are doing it right now, thousands of different activities to this computers to do it, that is what is called artificial intelligence. So what happens is that, let's say for example, you are a painter. You are painting a craft, say a picture you are making it in your office. So what happens? Instead of you making that painting, we call it art. Now you give the all the theme to the computer, and then exactly like your brain thinks, the computer will think and it will paint for you. So you can play at one hand your painting, and then you have a computer produced painting. You can compare at the end of the day, and you'll see that they are exactly identical. Similarly, I give you another day-to-day life example, like music. You can play the music by yourself, and based on what we have learned in the music, now you see you have all these modern gadgets. I'm not a musician, so what you call keyboards, right? Keyboards are well programmed, and so on the keyboard, all the manual functions we do, like playing the harmonium or piano, everything is on the keyboard. How bulky used to be the piano. Now the same activities which we used to do on the piano, now you can use it on the keyboard lot more simply, right? So what happens? Now you have converted all these manual functions to the computer of the keyboard, and the computer is doing it for you. Even you can program it. Say whatever music I am playing, say you are playing a violin. If you want you that violin to be programmed, computer can play a violin for you, right? Computer can play a keyboard, can play a piano for you. So this is all the example of artificial intelligence. Similarly, say for example, you are a movie maker. You are trying to make, right now movie industry people are more concerned about the artificial intelligence, because a lot of story writers, lot of cinema script writers, there is a strike going on right now. That's why I'm giving you this example in the United States, in Hollywood, which is called the place for the movie industry. And there is a strike by writers are on the strike right now. Who are these writers? You know how the movies are made. First, you have a movie, you have a story novel, like, for example, who was the British novelist, very famous recently?
Script, like
Uh,
script.
huh?
Script.
Yeah. No, who is the British novelist who was very famous in last 20 years? I'm forgetting her name. She has been making a lot of her stories. Her stories have been very famous. Her novels have been very famous all over the world. Anybody can think of. She is a British lady who used to write in the coffee shop. Harry something? Harry Potter? Harry Potter, who is the writer of that,
Oh,
right?
Harry
Harry
Potter.
Potter stories, right? She used to write in the cafe. Okay, so C is a story. So C makes. Let's see, for example, what happens. C makes a. C writes a story that is her creation of her brain, her intelligence. Right now, she creates that story. Now that goes to Hollywood. Now from that story, the movie writers, they will make a script for the movie. So they will reconvert that into a higher level product, you can call it, uh, into in the story making. Basically, they are also doing the story. The the original story is now rewritten into another story plot. Okay, now third level happens, that will be converted into scene wise. Different scenes will be, like, let's call it the 200 scenes of that movie. So that is called screen story. So 20 200 scenes now will be written again from that plot, movie plot, to 200 different screens. So 200 sub stories, you can call it. Now in 200 sub stories, now there will be dialogue. Say, for example, you and I and Brenda are players in that one scene, one screen. So we will be, of course, talking, right? We may have a character, but we'll be talking. So what is my dialogue? What is your dialogue? What is Brenda's dialogue? So somebody will be writing that. Okay, so now all this is done. Then this is how the whole screenplay is. Now finally all the writing part is done. Now movie makers has everything. That particular scene, me, you and Brenda, what we are going to talk, we have our dialogue, we'll memorize our dialogue, and then the way scene goes, we are going to play over it. So you see that one, how Harry Potter's story, she wrote in a cafe a big story one. Then another writer uh, again wrote a screen script. Then from screen script, it was converted into 100 different sub stories for different scenes. And then again from that 100 sub stories, we have the dialogues. So all these things have been done by 1,000 people, different people. Now, based on artificial intelligence, if you give all this data, uh, now the artificial intelligence can do it also for you. It will write a screenplay, it will write a sub-screen stories, it will write dialogue for you. That is what is happening. And that is why they are scared that your jobs are in trouble, artificial intelligence. So that's what it is. But who is in all of this? The artificial intelligence is ultimately back to the transistor, because it is the transistor which is making it happen. Okay, so right now there are the transistor companies who are making design chips design. Their demand is very high. Who are those? They are those who are the top company. I can give you some names. Microsoft is there. Microsoft makes software for it. It doesn't make the computer chips, it uses it. That's why Microsoft is user of the chips. Then you have NVIDIA, which is computer chips maker, designer of the chips. Okay, who designs the chips? So that is why NVIDIA is right now considered a leader in artificial intelligence. Okay, these two, Google is also. So Google, imagine it, that Google and IBM and many other companies, including Microsoft, they use those chips, and then from the chips they give software direction that, hey, I want you to write the screenplay, I want you to develop a dialogue for me, I want you to develop this and that. So they are doing all these functions. That is done by Microsoft, or just like movie industry I gave you. But ultimately this all instruction they are asking it to do, who is doing it? It is doing, the computer chips is doing it. And then computer chips is a machine, so it also works on a certain way, and that one is designed by, make it usable. There are a few companies like AMD, Intel, you have like NVIDIA. There are many companies who are designing it. Okay, So now that is what is happening right now. That is what is ultimately the artificial intelligence. So the bottom line is that it comes to ultimately, how do you make the computer chips? But before we go into making, like Brinda was talking about silicon germanium, I want you to understand first transistor, how it works. So that is why I was giving you the lake, which is a kind of source, and then the canal, which is like called drain, and then in the middle, I told you, is the sluice gate. Okay, so we also call in transistor gate. So now in the transistor, a small transistor, think about it. At one side, you have source, a tank of electron. Think about it, a lake of electron. A lake is full of all the electrons. And now you want to take some of this electron to the right hand side in a canal. Okay, as for your different application. Remember I was telling you that sometimes you need a lot more electrons because it is a summertime. You have to use a lot of electrons for your paddy crop or wheat crop. But then there are certain seasons you don't need that many electrons because you don't need that many. So you want very small amount of, like for example, electricity. Daytime use a lot more electrons in the than in the nights, right? So you have to regulate it. You don't want to waste your energy generating that much electricity in the night. Similarly, so you need a control, and that is the control is done by that gate, sluice gate I was telling you in the water case, right? So what happens is that now this electron whole mechanism is how do I transfer electron from source to drain through the gate? Okay, that is the thing. And then you will hear that there is 2 meg, 4 megabyte, 256 megabyte, gigabyte. What it means is that there are millions of transistors, they are dancing together, billions of transistors, because it's not that only one electron transfer has only power to make only one decision, which you can do is like yes or no, or don't do anything, right? But when you have to make a complex decision or many things, you need more transistor. So depending on how many work you have to do, how many decisions you have to make, you need more and more transistor. And that is why you need billions and billions of transistor. One or two transistor are not going to be work. Okay. So, but in all those transistors, individually, everybody is doing only three things. Yes, allow it, transfer of electron through the gate, or no, you are not allowed to go, or do nothing. Basically, even the third option right now, let's not use it. All we are trying to do is that on think about it. You have 1 billion transistor, an army of 1 billion transistor on the left hand side in the source sitting. Consider it like their rifles ready to go, and they are ready to fire 1 billion transistors. And now you have a control here. They are waiting for your order. When you give them the order, they will fire or they will go through the gate on the right hand side to the one, right? So everybody has to do that one. You gave a specific signal to each transistor, then each transistor will either go or not go. Go, no go. That's where the word comes, go, no go, right? There are two things they can do. Now this machine has, okay, very clear. So uh, this is exactly is the principle of transistor working, that you have at one side you have transistor source. Now in the middle you have a controller gate. On the right hand side you have a drain where you want it to go, and as a gate you have a control. So what happens is that in the semiconductor real life, you have uh, from the source, and then we put the electric voltage at the gate. When we put the voltage, it will create a path, or you can call it is open the sluice gate so that electron can flow. Okay, so since it is electrical work, so we create a voltage, and that as when we give the voltage, then sluice gate will open. You give the voltage, sluice gate will open. Now electron can move from the source to drain. Done. That's all is the transistor. Okay, I want you only to get it this one, that this is what is happening. The voltage you apply, voltage when you apply, then the source, uh, to drain, the gate we have in between, that sluice gate opens, and now transistor can move from source to drain. Okay, that is the main fundamental function. And now there are billions, 20 billions, 30 billions transistor, they're doing it. And then everybody has their own task. Some is firing like at in front of, like this, like that, straight. Somebody is firing at an angle. Everybody has their special instruction. All transistors, how you are going to fire when you go on this side. A billion army. Okay, so now question.
I think
Yes, I think lost the connection.
yes, they will join soon.
Yes, I try to remember this
Yes,
class in
yes.
the school. As in 12 years ago, I study electronic components electronic. I try to remember some
I
concepts.
think
Yes, I try to remember some concepts. This is why
yes,
first my question was about the yes, microchip have a million of transistor.
yes. So actually, Amarnath sir whole life invested in only semiconductor in the 1983 to 2020. Yes,
Okay.
yes,
All right.
sir.
Sorry, I
Yes,
got
sir.
disconnected. Something happened. So the kids left. Okay. So now let's go to the silicon germanium part. Okay. So now it comes to the chemical part. How do you make it? So there is, uh, we call it semi. Let's break it down. Semi plus conductor. What is semi means? Semi means exactly what we are talking about, like sluice gate thing. That, when you want, the control is at your fingertips. Basically, you want to control when to flow the electron, when not to flow. Okay, and conductor is conductor. So basically, at your will, electron will flow from one side to another. That is why it's called the semiconductor. Get it now, the meaning of it? Okay. Now
Yes,
the third part is that how do we do it? So there are, if you look at the periodic table, uh, they studied all this, that which one is. So if you look at the silicon, in the outer orbit, there are four electrons. Okay, and basic engineering, you all know that for a stable atomic structure, we need 8 electron in the outer orbit. Okay, so this is exactly silicon, germanium. They are in the periodic table. All of them are in the same group. So basically, all of them are have the electron only 4 at the outer orbit. So they are potentially uh, uh, candidate which can be used for semiconductor. So basically, what you do is that, uh, if you control the behavior, if you control the behavior, just like, let me give you another example. Like we do the therapy, we go to the doctor, and we doctor change our behavior, right? If we have any trouble, like, or same way, what we are doing is that right now silicon and germanium atom are, right now they are stable, and we are uh, we are going to play with them. Basically, what we do is that in their atomic structure, we do is that we make them, before I do that one, so you conductor, what is the conductor opposite? Insulator, we call it. Okay, insulator is what? Like pie wood you have. Can you pass electron through wood? No, it will not go. So that's why it is called insulator. Okay, wood will not go. But what about iron and copper? Can you pass electron through it? Yes. Okay. Similarly, if you take a silicon, silicon is nothing but our, in India we call it balu and sand. So most precious sand. Uh, so sand, you cannot throw. Electron will not migrate through that one. It doesn't. Okay. So now the whole game is that how you make the silicon and germanium useful so that you can flow the electrons through it when you want it. Okay. So that is what is the whole game of the semiconductor industry. Okay, that's what. So it is a physics, it is chemistry, it is mathematics. Everything is all together. That's why in this industry you have all kind of people working. Okay, and it's fundamentally you have to create the how should I say that it is just like a building a house. So I start. So basically just you take a silicon. In the silicon, basically how do you make it semiconductor? So what you do is that in the silicon you uh, implant some impurities, or you can call it, we add some other materials to it. Okay, when we add some material to it, then it behaves differently naturally because it's not a pure silicon, right? So over the period we have done the studies and we have figured out for which application there are bismuth is one, then there is antimony, there are a lot of different materials. We mix it at a certain rate, and then we make it first. We Their atomic structure we change it. So atomic structure which is right now stable, we make it unstable first by doing that, by bombardment of mixing another material with it. We call it implanting it. Once we have changed the behavior, just like it has gone through a therapy, the silicon has gone through a therapy, and now behavior is changing. Now it has become our slave. Now it is a semiconductor. So now once we have done that one, then now I have a control on it. Now I open the sluice gate, it will behave for me at my order. I'll say that I'll put the electrical voltage, and then that silicon oxide, SiO2, silicon, when it reacts with oxygen, it makes SiO2, which is nothing but a variety of sand. It is insulator, it is non-conductor, no electricity goes through it. But now, since I have implanted some impurities and I have changed the atomic structure, its behavior has changed. Now has become a semiconductor. And now that semiconductor, once I apply the voltage, now it is at my fingertips. How much I want electron to flow from source to drain, it will do it. Okay, so this is what is, and semiconductor. And so silicon can be used, germanium can be used as a base, and now you can make a chips on top of it. Okay, that's it. Now there is a lot of different things happening, which is chemical part. I don't need to explain to you. So now transistor part you guys understood. Brinda, are you with?
I think
Okay, Brinda, did you
Yes.
get the basic of where the silicon and germanium comes in the play? Yeah. So
Yes.
basically, it is the basic material for computer chips making. You start making chips. So we take the way we do it is that there are factories. We started with the 4-inch silicon, just like pizza. You have a small size pizza, and then you have a 4 to 6 inch pizza, and then 6 to 8 inch, and now 12 inch, 16 inch. Exactly the same way semiconductor, you took a pure initially, before even I came into this industry, it was 4 inch and 6 inch. Uh, that is where they started making chips. When I joined in 80s, it was 8 inch wafers. We call it wafers. We cut the slice just like salami slicing we do. You have a salami and then you cut it in small slice, or cheese you cut in small slice. Similarly, you first make a there is a some complete separate industry how to make a pure silicon or pure germanium. Then you cut into a small thick 1/8 of an inch thick slices. We call it wafer. Okay, so this is the pure silicon or pure germanium wafer. Now that is a raw material for company like um, Intel or IBM or Micron to use it for making the semiconductor, depending on what kind of design they have. What kind of, like I said, there can be varieties of different types of computer chips can be made, but this is how is the basic material is the silicon. And then silicon, all we do is that we add some impurities. Based on that, we make that silicon or germanium little impure, and that's how they become from non-conductor to conductor. Now
Yes.
they are not conducting material. Whenever we want, we can utilize that one. Okay,
Yes.
so now basically in the there are 400, 500 different steps. It will be a completely different topic of that one, but I want to give you the basic idea. So now we start with the silicon. Now we first what we make is we make the transistor. So now we have made the transistors on that silicon. Imagine it 8 inch pizza will be like how many? 8 slices. 8 slices pizza size. Domino pizza in India is available now, so you can think about Domino's.
Yes. It's
Eight
available.
eight inch is your pan pizza in India, I think, and 12 inch is the standard medium we call it here. So 12 inch. So so same type, very thin wafer you can think of. We take it now. We start that in the semiconductor like IBM factory, chip factory, or Intel factory or TSMC factory. We start the process now. Okay, so now the first part will be we make the computer transistors, and there are 300, 400 processes it is used to make that, and we call it front end. Why we call it front end? Because we have made up to transistor, and transistor means like source, we make drain, we make everything, because our raw material is now silicon or germanium. Now we have to make a source, we have to make a drain, we have to make a gate. All these things we have to make on top of it, and you have to make it billions of them. Okay, it's not like one or two, you need a billions of them. So there are different design process. There is completely a design group who has that responsibility. Everything is, it's not one man job. Nobody does one thing, right? So by proper design rules, everything is happening. And so now you first make the pure silicon. Now you make on the pure silicon in the factory clean room environment. You make the source and drain and gate. And why it is clean room? Because you are talking about here at angstrom level. If there is any impurities, imagine, and you have to make so many levels of that one to make all these source and drain, so many layers after layers. You are making all it is just like yeah, that is what I was trying to tell you. Imagine about 50 or 70-story building which you have in Manhattan or Shanghai someplace, right? So now fundamentally, basically, it is nothing like, it is exactly like building the 50-story building. Okay, many processes, all you are doing it at a different level. You have different layers to do that function. So but the process is the same. At one layer you deposit it. Okay, now you deposit, you have to cut like different places because you need for different things. So the term we use it, thin film deposition. Then we will be using etching. Etching is that wherever some areas you want film to stay some area, you don't want film to stay. You want to dig a hole. So you will dig a hole into that one so that you can go to the different level of connection you can make. Okay. So that is called etching. So thin film deposition, etching, you keep doing, and the same thing you do it at different permutation combination at different layers. So so on the silicon, we have to deposit so many layers. One layer, and we play with it. Another layer, we play with another layer, we play with it. All these doing, finally, we have made the transistor. Okay, that part is done. Okay, now once the transistor is done, and we keep checking by electrical test. Now the question is that you have to wire it very electron, just like electric wiring we do in the house, in the apartment, in the thing. It has to chips, ultimately goes to a computer. Every computer you connect to the module to your computer, and your computer is connected to the house what you call socket, right? That's where the power is
Yes.
coming. And now, so think about it now, the from the house power, let's take our laptop or the house power, or so how from the house power it has to connect all the way to the uh, you need to remember, I was telling you that you need to give electrical voltage so that it can transistor can uh, open the gate, and then the electron can move from source to drain, right? So you need the power to come all the way from house to there. So how do you do it? You have to connect, right? So front transistor is made. Now we call it back end, which is nothing but the connecting the transistor to the power source. Okay, that is called the back end. So front end, you started with the silicon. In the front end, you have made the transistor gate. Everything is ready now. Transistor can function, but you need to give a voltage to it so that transistors can do on and off. Switch on, we also call it many times, just like source to drain. You open the gate. We also call it on and off also. Transistor switch on and off. Just like switch we have in the walls, we call it on and off. Okay. So for that we need to connect, for that voltage of that transistor is now connected all the way to the wire, through the wires to your house power source, right? So how do you do it in the wafer level? So you will be surprised to know, just like you are using the copper wire and aluminum wire, we also deposit a a film of copper, and that's how at the atomic level, atomic level, the what you call the transistor is connected all the way, different layers. There is a way of doing that one. And so imagine in the back end, mainly now it is copper connection. So we make a connection to that transistor all the way to our computer power, and then from computer power to our house power. Okay. So so this so this is uh, um, this is all is done into the first in the transistor level, that you create a transistor, then you create in the front end on the silicon wafer, and there are billions of them. On the back end you will create a connection. So now the transistors can have the capability to now communicate with the computer, and now it is ready to be used. So what we do is that on the wafer, Brenda, your silicon or germanium, whichever wafer you are using, now each individual chips are ready. If transistors are ready to be used, so we cut them into small pieces, just like you slice them on the pizza. You have a big 8-inch pizza and you cut into 8 slices. Same way, you cut into these computer ready chips into small pieces, just like our picture icon is here, a small rectangular thing. We cut it into rectangular pieces, these computer chips. And then these computer chips, when they are cut into small pieces, now they can be now assembled. There is a assembly factories are mostly in like Costa Rica or Malaysia or Singapore. Many other countries can do. Chips making is very special art. Not everybody can do it, the chips. But now you have the chip, you supply to any place. You can do it in India. Now the chips, now you put it in the assembly test, you make what is called module. Module is like you add some on the chips, you add some bells and whistles, all those things, make it usable, so that all you do is that you take this module from here, from your storages, and if you are making a telephone, all you do is that different type of modules, for different functions, which are nothing but different chips. Now you can simply plug in. That's why assembly is very easy, anybody can do it, right? It's not very brainy work has been done already in the chip making. Now you assemble it, you put it together, in the any assembly factory, all the chips in the module, and now you test it, make sure it's functioning very well, what it's supposed to do. And then that's it. Then those modules are, you do the mathematical sampling testing. You don't want to test everything, otherwise it'll go bankrupt, right? So you want to see sample level, depending on, over the time you learn it, and then you reduce the sampling. This is your operation task, Pankaj. Same operation any place you do. So you sampling frequency you have to cut down, and as your yield is higher and higher, and then basically your module chips is ready to go to sell. You sell now to different companies. Like for example, you can sell these chips module to assemble module to, say for example, any company, let's say for example, Apple or Samsung or India Ambani. They will, now they can use it into their factory, in their telephone assembly plant. So that's how is the whole transistor migration now. Now, like I said, that in this phone we have billions of transistor. They are doing all these functions. Three functions actually. Ultimately, it comes to only two things: either yes or no. There are billions of transistors in this telephone. They are doing yes or no, right? Go or no go. That's all they are doing. But collectively, billions of them together, when they make that decision, we are able to talk. We are able to converse, and that is what is the whole thing is art. So telephone is also an example of artificial intelligence. Okay, our laptop is also artificial. This is all artificial intelligence. It's not, artificial intelligence is not by itself a new machine.
Okay, and then it's possible to join the different transistor, no matter it's a silicon or germanium. Is it possible to
Exactly.
join?
Yes, that's what you
Okay,
do. So, for example, in this.
because sorry for interrupt. Because I remember 12 years ago I studied about the electronic circuit electronics, and I remember the silicon needs 0.5 volts for broken the boundary,
Hmm.
and the germanium need to 0.7 volts for
Yes,
broken the boundary,
yes. Okay,
and then it's possible to join this transistor, right?
that's correct.
Okay.
So basically, it is just like, let's take it, that you have Toyota car, and you have Honda car, you have Civic, you have Tesla car. They all have a different little bit variation. They are all cars, but they are doing different functions, right? Okay. So now this, you can make your computer chips on silicon. You have a choice. You can make your computer chips on the germanium, but since they are two different raw material, they are not going to function alike, right? So uh, you have to utilize silicon properties, and then you have to play with it to do your function, which we talked about to make a transistor. And similarly, you have to use a different similar function, but at the different scale on the germanium, to get the same result out of it. So that's why they they work on different voltages, or there are different parameters. Okay, is
Yes.
that clear to you?
Yes.
So it is basically because of their atomic structure. Their atomic structure is different. So if the atomic structure is, because there you have so many, if you look at the electronic orbit, you have so many orbits. Silicon has, I'm forgetting right now, I don't have period table in front of me, but silicon is, I think germanium is heavier than silicon. So germanium has more orbits of electrons than the silicon has. So basically, you can think about it that if the information is going to pass through a silicon semiconductor versus a germanium semiconductor, there will be two different time. It will not be exactly the same time. Okay, suppose by natural, if you put the same voltage to both of them, you get your transistor, your electron travel on the silicon will be different than the germanium. But suppose if you have a function that if you want to use the same time, suppose time is important for you, you want to make the say, let's call it for now that germanium, through germanium information flow is slower than the silicon. Then if you want germanium transistor to also flow the signal just like silicon, all you have to do is that you apply more voltage. Remember, I was telling you that switch
Yes.
gate, you have a control, right? If you want more water, you have to open more
Yes.
switch
If you
gate.
wanna broken the boundary more easy, you need to put more
Exactly,
voltage.
more voltage. So
More.
that is,
Yes.
that's why you can control it depending on what is your requirement. You first import you, once you have mastered that, okay, now you know what is the rate of their flow for both silicon and germanium. Now you can play with it depending on
Yes.
different applications. You have so 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 the bottom line is that now you the main thing is that from the silicon, which is a non-conductor, or germanium, which is non-conductor, we first make by implant semiconductor. Now we have made them our slaves. Now we can make the transistor on them. Then we first make transistor on the, we call it front end processes. There are 300-400 of that. Then we do the back end processes. It is both front end and back end together. It's just like house building, 50-60 story building. At different layer, we apply different thin film, we different material, and then basically, we want them to work the way our design works, right? Basically, that's what it is. But it is nothing but thin film deposition, etching, making layer. Now next layer. Now next layer. Our next layer. This is what we do, and then after that, once it is done, all the copper wiring is done in the back. Then it's done. Then we cut it into small pieces. Then those small chips we mount. There is called there are different technology, assembly technology. You have to assemble it with another piece. We call it what is that is called. That is also silicon, but in the when we make the module, there is substrate, we call it. So on the silicon substrate, we attach that chips now. There are different technology to attach the chips now, addition by addition. So now, and so now substrate has even, it is an industry by itself. So
Yes.
it has basically now, it is a substrate job is to take the electrical signal from the chips now to the your outside the outside outside of it to connect to something else. Okay, so now chips is connected to substrate. Now substrate is connected to another outlet, which is in the module. And now module is a complete assembly, which is now ready to be sold or put into any machine, whether it is telephone or computer. And you have different module. For example, Intel, uh, Intel and AMD or Nvidia, they make CPU. So if you look at your phone or your computer, you will have one type of chip. This is called CPU. Take the pictures. Then Microns and many other Toshiba, they make memory chips. So you
Yes.
need another module which is memory type. So like that, there is controller modules. So
Yes.
which control the flow, how we, like our hand and feet movement. So there is control. There are different sensors, right? So all those, there are different different computers are designed to do different function, but ultimately the main thing is that transistors to understanding that it is yes or no, flow, go or no go, right?
Okay,
And
yes, that transition will take the decision,
that's
and more
all
transitions
and
they have
and
more
and
risks.
and that transistor decision of yes or no, mathematically we have converted into 0 and 1. When it is no, then we call it 0, and then yes, it is 1. So if ultimately all the machine language, if you check, you know, that will be a combination of 0 and 1.
Yes,
Nothing. Yeah, that's why it is 0 and 1, because it is either, these are the only two decisions you are making, either go or no go, right? That's all it
right.
is. Every transistor, so all the billions of them, they have this decision, and then we combined all the decisions together, then you have the product which are useful for you and me to utilize in our daily life.
Yes.
Okay.
Yes, this is a good topic. I think it's late for Pancacha because I think it's sleepy now.
Yeah, I think that's
Yeah.
enough now for today. Yeah. So Malikji is not covered, so I was saving this for the day like this when Malikji is not here.
Yes.
We can.
Thank you so much for the information and try to
Hey,
explain.
Brenda, I have never seen your real picture. Can you show us your real face if you don't mind?
Yes, but we have one problem with my computer.
Oh,
But the
okay.
next week, change my computer and open my webcam.
Oh, okay. Yeah,
Okay, the next week, yes,
I
the
want to
next
see
week,
your real
change my
face.
computer.
Okay, good.
Yeah,
All right, we
the
will do
next
next
week,
time.
change
Yeah,
my
next week.
computer and open my webcam.
Okay.
Okay,
All right.
okay.
All right
Thank
then.
you for the
Good
time.
night. Bye. So, okay, I don't make a picture of this, okay? Because I have utilized many proprietary information which I should not be talking. Okay, so
Okay.
no, don't make
Pankacha, you
video.
are talking in mute.
Oh, okay, sorry.
Pankacha, you are talking in mute.
Sorry, sorry. Yes. So it's a till now I am recording this, sir. So can I not save this?
Yes. Now,
Amarnath?
Amanaji, you are talking in mute.
Yes.
Okay,
Yes.
I think you can. I didn't say anything. I didn't share my screen, so it's okay. You can broadcast it. That's not a problem. Okay, this is good. Okay, good night, everybody.
Good night. Good night.